Welcome back for Chapter 2, Part 2, where we take a look more at molecules and ions. And we're going to start by just doing a brief review of the periodic table. You will have a periodic table in your reference table this year. It will not be nearly as detailed as the one you had in your first year of chemistry. So, what you need to be able to do is identify the main groups. And the main groups that you'll be responsible for knowing the names of or knowing the charges of the ions in that group are the alkali metals in group 1. So, this is, well, it starts with hydrogen, although hydrogen is not a metal. We'll talk about that later. And then you have lithium, sodium, potassium, all the way down. Group 2 are the alkaline earth metals. So here you have beryllium, calcium, magnesium, and so on. Over in the non-metals, you're going to have the halogens. That's group 17. So that's your fluorine, chlorine, iodine, bromine, not in the correct order. And then lastly, all the way to the right, these are your noble gases. So these are the groups that you're responsible for knowing. Last year, we talked about the transition metals, and we will talk about that a bit in AP chemistry. But for right now, we're going to focus on the groups that I've pointed out here. Another thing to be able to pick out from the periodic table are your diatomic molecules. These are important to memorize, and there are 7 of them. You have hydrogen up here in the upper left corner, and then the rest of them are found over here on the right. They're all nonmetals, but hydrogen is over here in group 1. So we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. I refer to these as the Brinkelhoffs because when you rearrange them, you can spell the word Brinkelhoff. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Those are your Brinkelhoffs. However, you want to remember them is fine. Some people remember 1 plus 7 because it forms a 7 over here. Whatever the case may be, you need to know that these elements exist solely as diatomic molecules when they are by themselves. So when it's purely hydrogen, it's H2, the formula. When it's purely nitrogen, it's N2. They don't need to retain that subscript of 2 in a chemical compound, and this is the biggest misconception. That is going to be dependent on the charges of the ions that are also in that compound. Speaking of ions, ions are formed when atoms, which are neutral substances, as we discussed in the first part of chapter 2, when they gain or lose electrons. And so it's very important that you understand how positive and negative ions are formed and the most common ion charges for certain elements in the periodic table. So, in your first year of chemistry, you had a reference table that listed these ion charges. You do not have that anymore. You're just going to have the elements and where they are in the periodic table. It is up to you to look at the substances, look at the group that those elements are in, and identify the most common charge that those ions will take on. So, for example, all elements in group 1 will most likely take on a +1 charge because they have one valence electron in their outermost energy level. Therefore, losing that one valence electron will be the easiest. All elements in group 2, your alkaline earth metals, those are more likely to take on a +2 charge because they have two valence electrons in their outermost energy level. And these are called cations. Cations are positive and they're formed when substances lose electrons. Those are typically metals. So that's why you have them over here on the left side of the periodic table. Over here on the right, the elements that are highlighted, these are the elements that you should know the common ion charges for. You'll notice group 1, you can ignore hydrogen up here. That really shouldn't be in there. It does take on a negative charge, but not often. But as far as the halogens go, halogens have 7 valence electrons, so they only need to gain 1 to become a full octet in their outermost energy level. Therefore, their most common charge is -1 because they gain an electron. When they gain that electron, they now have one more electron than they do proton, and that's when they take on the -1 charge. Elements in group 16 I know it's labeled 6A here. This is an old periodic table, but this is group 16 that you're familiar with. They gain 2 electrons, so they take on -2 charges. Nitrogen has 5 valence electrons. It'll gain 3, so it'll take on a -3 charge. And then I failed to mention aluminum. Aluminum, even though it is on the far right or on the right hand side of the periodic table, it's considered a metal. It loses electrons. And since it has 3 valence electrons, it'll take on a +3 charge. Knowing these charges is going to make your life much, much easier when it comes to anything really in AP chemistry. These are your anions because they form negative charges. These are your cations because they form positive charges. The ions that we just talked about were made up of one element. Polyatomic ions are going to be ions that are made up of 2 or more atoms chemically bonded together. You had a chart in your reference table last year that listed all the polyatomic ions. You will no longer have that. Because of that, and because of the need to be able to look at a formula and be able to name it or write it quickly, part of your summer assignment is going to be to memorize certain polyatomic ions. I have linked those polyatomic ions in your summer assignment sheet. I have created a Quizlet that will help you remember those. That is also linked in your summer assignment sheet. And so I encourage you as the summer goes by, as school gets closer, to start reviewing your polyatomic ions. Some examples are given below. We have sulfate, chlorate, nitrate, a positive one called ammonium. And you can tell here they're polyatomic because there's more than one element chemically combined, yet the entire group of atoms has that -2 charge in this case. So it's not just one element that has that charge. And so what this all brings us to is writing formulas. And the main idea here is that compounds are electrically neutral. In order to make a compound, in this case, we're talking ionic compounds, a metal and a nonmetal, you're going to have to balance out those charges. So you see an example here. We have magnesium in group 2 with a +2 charge. We have nitrogen, which is in group 15 with a -3 charge. When they form a compound, they need to balance out these charges. So one of each isn't going to do the job because then it wouldn't be neutral. So if we have 3 magnesiums, 2 times 3 is going to give us a charge of +6 for our 3 magnesiums. In order to balance out that +6, we need 2 nitrogens since each nitrogen has a -2 charge. So as you can see here, kind of a shortcut to doing this is what I call swap and drop. You swap the charges and drop them down to the subscript values. If you end up with numerical values as your subscripts that can be reduced further, you can do that. So that swap and drop is something you can use, but I encourage you to think through it to determine how many of each you'll need. Some rules for writing formulas. The cation is always written as the first symbol, so the positive ion, and you're just going to use the full name of the cation when you are writing the formula name. So if the first cation is sodium, you're just going to call it sodium. There's no dropping any of the endings or changing any of the endings like there will be with the second element in the compound. If you have a cation that has more than one choice of charge, and that's typically your that's typically your transition metals, you're going to include a charge as a Roman numeral. Now, you do not need to memorize all of the elements that have more than one choice of charge. More often, you'll just have to recognize that if a Roman numeral is given in a name, that's what it represents, the charge on the first ion. The anion is written as the second symbol, and you're going to change the ending of this one. So you're going to use the first syllable, and then you're going to change the ending to IDE. So for example, oxygen, you take ox, and then it becomes oxide. Nitrogen, you take the first symbol, which is nitr, and you end it with ide, so nitride. Phosphorus, it's phosphide. So you're going to drop that ending and add IDE as long as it's an individual element. If it is a polyatomic ion, that's even easier. You just use the name of the polyatomic ion. So if you have sodium as your positive ion and sulfate as your negative ion, you just name it sodium sulfate. Some of the ions that I ask you to memorize in AP chemistry are what we call oxyanions. And it's important to recognize the pattern in naming these. So the halogens are going to be the most common oxyanions that you're going to see. And what that means is that they're oxygen with a halogen, and there are subsequently more oxygens added. So the one with the fewest ions will always have the prefix hypo, and it will end in ite. So for example, this ion here is hypochlorite. The second fewest oxygens is just going to end in ite, so you drop the prefix. So this ion here is chlorite. The one with the second most oxygens is going to be 8, so this is chlorate. And then the one with the most oxygens has the prefix per, and this is if it typically goes above 3 oxygens. If there are 4 choices, the one with the most oxygens has the ending 8 and the prefix per. So this would be perchlorate. And this is the pattern that it would follow through all of those halogens. So if it were a bromine, it would be hypobromite, bromite, bromate, and perbromate. So what I'd like you to do, and I will do one with you first, is practice this naming. So we'll look at the first one here, calcium hydroxide. We're actually going to practice writing the formula first. So calcium has a charge of +2. How do I know that? Because it's in group 2 of the periodic table. Hydroxide is a polyatomic ion, even though it does end in "ide." It's one of those ones I encourage you to memorize. Hydroxide is a polyatomic ion made up of 1 oxygen and 1 hydrogen with a -1 charge. So if calcium has a +2 charge, and hydroxide has a -1 charge, we need 2 hydroxides. And so the formula that we're going to end up with looks like this. We're going to put those parentheses around the OH so that we indicate we have 2 OHs and not just 2 hydrogens if we had left off those parentheses. So I know this is a review from first year of chemistry, so what I'd like you to do is pause the video, try the rest of these, and then come back and check your answers. Hopefully you had a chance to work on all of these. So we'll just quickly go through the answers. So for the next one, our formula is going to look like this. We see our Roman numeral here indicating that copper has a +2 charge. Nitrate has a -1 charge, which is why we need 2 nitrates. So we're going to put those in parentheses. Next one, potassium has a +1 charge. Dichromate is a polyatomic that has a -2 charge. So we need 2 potassiums to balance out the chromate. No Roman numerals needed because you are indicating you have 2 potassiums, not 2 chromates. Sodium iodite. Iodite is going to end in ITE, which means it has the 2 oxygens there. And this has a charge of +1, -1, so we only need 1 of each. Magnesium acetate. Acetate is a large polyatomic ion, but we do need 2 of them because magnesium is in group 2 with a +2 charge. Acetate only has a -1 charge. Another Roman numeral indicating that iron has a +3 charge in this compound. Carbonate has a -2 charge, so we need 2 irons and 3 carbonates. Ammonium chloride. Ammonium is a positive polyatomic ion with a +1 charge. Chloride, since it ends in IDE, we know that it is just the element chlorine by itself. So that is our formula. And then it popped up a little quicker, but zinc sulfate. Zinc does have a +2 charge. And this is one that I encourage you to remember, even though it's not one of the highlighted ones on a previous slide. Zinc is a transition metal, but it only has 1 charge. It's +2. And if you remember that, it'll make your life a lot easier. Another one that's common that only has 1 charge is silver. Silver only has a +1 charge. So these are things that we'll practice enough throughout the year that I think that will help you memorize them. And finally, going the other way, I'd like you to stop the video and try these where you're naming these formulas. So take a minute, go through these, and then restart the video when you're ready to check your answers. Okay, so taking a look at the first one, we have sodium sulfate, polyatomic ion, we just name it, no Roman numerals needed because sodium is in group 1, it only has 1 charge. Next one, barium permanganate. Chromium per bromate. We do need Roman numerals. How do I know what the charge on chromium is? Well, I look to see how many per bromates I need. I know per bromate has a -1 charge. So if I need 3 of them, it must mean the charge on chromium is +3. Next one is potassium thiocyanate. This was a mistake on my part. Thiocyanate is not one of the ions you need to memorize. So if you didn't know that one, please do not panic. Next one is copper 2 nitrate. Again, need the Roman numeral. Copper is a transition metal with more than one choice of charge. And lastly, silver chloride. So there are plenty of practice problems available to you on the summer assignment, part C, I believe it is, where you are being asked to do the same thing, write formulas, name formulas, and then the answers will be posted. There are also a few practice websites that you can get to via my website on the summer assignment page. So I encourage you to practice those if you find you need more help.